In this tutorial, I'm going to show you how to use the Markov chain in Fabricate to simulate a realistic flow through different states. So in this particular example, we're going to simulate web application traffic, specifically somebody navigating through an e-commerce application to purchase a product. So a realistic flow, or sort of the ideal flow, might be the home page to a category page to a product page, then to checkout, and then some sort of purchase confirmation. Of course, in real life, users don't necessarily exactly follow that flow. They might meander around, browse within the site, go from category to product, back to category, etc., until eventually they either check out, maybe even continue shopping after checking out, or just mysteriously drop from the application because they didn't want to buy anything. So a Markov chain allows us to define the probability of transitioning from any given page to any other page. It's really useful in general for defining how state machines work. So let's get started. I'm going to create a database called weblogs, and I'm going to create two tables, sessions and page views. So for sessions, we're just going to have an ID, which I'll just use an auto-incrementing number, and then I'll also have a start time for each session, which I'll use a date time with type series. I can just pick the defaults here. It'll start 1 year ago, and then it'll be between 1 and 10 minutes for each session. So it's sort of simulating getting a new user session between every 1 and 10 minutes. Okay, so there's our sessions table. And now let's have a page views table that refers back to sessions. So I'll add a foreign key session ID. Let's start by defining a cardinality, basically how many page views we want for each session. We don't necessarily have to do it that way. We can also let the Markov chain decide when the user drops from the session, but I'll show you how to do that later. For now, let's just do between 5 and 10 page views for each session. So you see we have our session ID repeating between 5 and 10 times. And then now let's use the Markov chain generator to generate the actual page. So Markov chain. And so the way Markov chain works is you have to define the probability of transitioning from a previous value to a next value for all of the possible states. And so in this case, state is going to be a page. And you can define the starting states by just not having a previous value. So you can add transitions manually by clicking here, and that's what I'm going to do. Or you can generate them using an AI prompt. Just describe what you want done, and the AI will do its best to generate a Markov chain state transition table for you. Or you can also import them from CSV. So if you create a CSV with these columns, then you can import an entire state transition matrix from CSV. But I'll just do it manually. So let's define our starting state. Let's say we're going to be really idealistic here. We're just always going to start from the home page. And so previous value, I'll just say none, and next value is slash for the home page, and probability is 100%. Okay, so from the home page, let's say we generally go to a categories page. So something like this. I'll say that that's maybe 80% of the time, and then maybe 40% of the time we go to a product page like this. Okay. Okay, so now we have to say where we're going to go from categories page. Let's say from categories page, we go to the products page maybe 80% of the time, and we go to the home page like the remaining 20% of the time. And then for products, let's say we go to checkout something like 25% of the time, and we go back to categories like 75% of the time, maybe. And then now for checkout, we're going to go to purchase confirmation like let's say 50% of the time they actually purchase something, and 50% of the time they go back, let's say, to a product page. So you can see we don't have to define a probability for every page going to every other page. We could say, some pages only go to certain other pages. And then they also don't have to add up to 100. Now, so far, each previous value group has added up to 100. But if I take away from that, in fact, hold on, I made a mistake here. This needs to be 50%. If I don't make them add up to 100, that increases the probability of generating a null for the next value. And we can use our foreign key generator to stop generating rows on a null if we want. But first, let's just actually see the nulls. So let's say that purchase confirmation, which is the last state we haven't defined yet, let's say that 25% of the time we go back to the home page, and that's it. Like otherwise, implied 75% of the time, that's the end of the flow. Before we save this, we need to partition by the session ID. So basically, it starts a new flow as we go down the rows every time the session ID changes. So let's save and close and see what we get. Okay, so now you can see we always start on the home page, just like we said. So 1 starts on the home page, 2 starts on the home page, etc. And then it uses the Markov chain to probabilistically navigate through the site. This first person browsed around and never got to purchase anything. Second person had a shorter session, so they didn't either. But third person actually browsed through, got to a product page, went to checkout, went to purchase confirmation, and then it just generated nulls from there. So that should represent the end of the browsing flow, but of course, in this schema, it doesn't kind of make sense to have a page view with no page. So what we can do is go and adjust our session ID foreign key. Instead of using a uniform cardinality, we can use this option until a column is falsy. So if we point that to the page column, it'll basically generate rows up to a maximum. So you could set this to anything up to 10,000. And it'll stop when the Markov chain returns a null. So you'll never actually see a null in the data. And so if I hit apply changes here, and so now it's actually the Markov chain that's deciding when each session ends. And so in this case, this first session went all the way through to purchase confirmation. Second session did as well. In fact, they all do, because basically our Markov chain decided that you'll always get to a purchase confirmation. So if I wanted to stop that, I would have to go in here and reduce some of these probabilities to add up to less than 100. So if I went and said that, okay, from the home page, like maybe 60% of the time you go to a category page, and 10% of the time you go to a product page, and from categories, maybe 60% of the time you go to a product page, maybe 5% of the time you go back home. Products, maybe this is fine, so we'll always go back to a category page. Checkout, let's say maybe sometimes you just drop from checkout, so instead of going back to a product page 25% of the time instead of 50% of the time. So that should now actually make our browsing flows end a little sooner. So if I hit apply changes, yeah, so now not everybody's going to actually purchase things. You'll see like 1 here, they just sort of browse around, but eventually give up. Same with 2. 3 now actually goes through a purchase confirmation, and in fact goes back to the home page and does a little browsing afterwards. 4, does the same as well. And so you can see this generates a realistic flow. It's not a perfect flow in that it doesn't necessarily go from home page to categories to products. It follows a more realistic distribution. But still, you can have things that are very strongly weighted towards a particular outcome. Like in our example, the only way to get to purchase confirmation was through checkout. So you'll always see checkout before you see purchase confirmation. And so in this way, you can use Markov chains to simulate a realistic set of state transitions. And that has many, many different applications in all sorts of different domains. Okay, now that we have a realistic flow through the different page types, let's actually turn those page types into concrete URLs, because you wouldn't have a variable like this probably show up in web blogs. You'd probably have a real URL with a real ID. So we can add another column. Let's call it path, or maybe URI. And let's use the SQL generator for that. To, let's say, replace in page ID with a random number. So fab random between like 1,000 and 9,999. So we could, have a different range of numbers for like categories page versus products page. We could make it more sophisticated, but for this purpose, I think it's fine. And so now we actually have, real numbers in place of our ID here, but we still have all the probabilities of transitioning between the specific page types. So in this case, we probably actually just want to hide the Markov chain from the output. So I'll click hide this column when exporting. And then now if I was to export this data into a real database, I would just have session ID and URI, and I wouldn't have the page column here. Then lastly, let's add the timestamp for each page view. And so we want to start each session at the start time that we configured here. So to do this, let's first import start time using column from another table. So we'll pick sessions.start time by matching the session ID. And so that'll give us the start time for each session. You'll see it's just repeated as long as the session value stays the same. And then we can generate a time series based on that. So let's call a new column timestamp using the datetime generator and using the series type. We'll start not at a fixed value, but from the start time column, and we'll partition by the session ID column. And maybe we'll change the interval. Instead of between 1 and 10 minutes, let's do between 10 and 20 seconds. So now we have our time series. So we have a timestamp for each page view, and it starts at the start time for each session. So the last thing is we would probably want to hide start time from the output as well, since we're just using as sort of an intermediate column to calculate our timestamp. So this is really the end result that we wanted. So now we have a page views table with a certain number of page views for each session. The actual number of rows generated for each session is determined by our Markov chain. So if the Markov chain decides that the browsing flow ends, then it does. Otherwise, it keeps going. And we have a timestamp that follows a time series at the start of each session ID, for each page view as well. So in this way, we've generated realistic weblog, page view data using Fabricate's Markov chain to model a realistic shopping flow.